Will humans ever escape the Milky Way? Wormholes demystified. Since the beginning of recorded time, one question has echoed through the ages, across tribes, civilizations, and centuries. What lies beyond? We built fires and looked up at the stars. We sailed across oceans, then skies, then space. We sent probes past Pluto. We landed robots on Mars. We dreamed bigger than any other species ever has. And now, we dream of leaving our galaxy. The Milky Way, our galactic home, is a swirling island of over 200 billion stars, stretching more than 100,000 light-years across. It's a place we've barely begun to understand. Yet, already, our eyes are turned outward, to what's beyond. Just outside our galactic borders lies a universe so vast, it defies imagination. Trillions of galaxies, endless possibilities. But between us and them lies a cruel, cosmic truth. Distance. Even the closest galaxy to ours, Andromeda, sits 2.537 million light-years away. If you boarded the fastest spacecraft ever built and left today, you'd still be on that journey when Earth was long gone, when the sun had died, and even our memory had faded into dust. So the question remains, can humans ever escape the Milky Way? For centuries, the answer was no. The distances were too massive. The energy demands, unthinkable. Our technology simply wasn't good enough. Even traveling at the speed of light, a limit we're nowhere near reaching, it would still take over 2 million years to arrive. And yet, a radical idea began to take shape in the minds of theoretical physicists. What if we didn't have to travel the whole way? What if there was a shortcut? A tunnel? A bridge? A tear in the fabric of space-time? A wormhole? Wormholes are one of the strangest predictions of Einstein's theory of general relativity. They are theoretical passages through space and time, gateways that could link one part of the universe to another instantly. They weren't invented by science fiction. They were uncovered by mathematics. Imagine space-time as a giant sheet of paper. Two distant galaxies are marked far apart. But what if you could fold that sheet and punch a hole straight through? Suddenly, those galaxies are right next to each other. That's what a wormhole does, if they exist. For decades, wormholes were dismissed as beautiful theories that couldn't exist in reality. They required exotic forms of matter. They would collapse the moment anything tried to pass through. And yet, scientists kept searching. Then came the breakthrough. In the year 2139, a team of astronomers at the Event Horizon Array discovered a gravitational anomaly near Sagittarius A*, the supermassive black hole at the center of our galaxy. But this anomaly didn't behave like any black hole they'd studied. It didn't destroy matter. It didn't emit deadly radiation. It was strangely stable. Balanced. It was quiet. Dr. Alina Ramesh, a physicist who had dedicated her life to studying hypothetical wormholes, looked at the data and whispered 4 words that changed everything. This is a doorway. The anomaly was named X13, and it became the most studied object in human history. Years of simulations, particle readings, and gravitational mapping pointed to one conclusion. This was a naturally occurring wormhole. And not just any wormhole. It appeared to be stable, accessible, and large enough for a spacecraft. The world held its breath. The first mission was unmanned, a probe called Starchaser 1. Launched in 2152, it was built with radiation shielding, AI navigation, and quantum transmitters capable of sending signals across intergalactic space, if it survived. It entered the wormhole. Then, silence. 1 hour. 1 day. 1 week. Nothing. Then, on day 12, a signal. It was faint at first, then grew stronger. The location tag made no sense. It had come from outside the Milky Way, in the Andromeda galaxy. The wormhole had worked. Earth erupted in celebration. But that was only the beginning. A human mission, Mission Infinity, was planned in secret. 6 astronauts, trained in both science and survival, were selected for what many considered a one-way trip. The ship was launched 2 years later. As the world watched, it disappeared into the wormhole, and 12 seconds later, reappeared at the other end. The crew was alive, healthy, and standing on the edge of a new galaxy. Their first transmission shook the world. We have arrived. 2 suns rise over this world. The air is thin, but breathable. We are surrounded by life. Alien, but beautiful. We are not in the Milky Way anymore. They named the new outpost Horizon Point, a new chapter in human history. So, can humans ever escape the Milky Way? The answer is no longer if. It's when. Wormholes may be rare, unpredictable, and dangerous. We still don't know how many exist or how long they last. We don't know what rules govern them, or if they can ever be made artificially. But they exist. They are our bridge to the stars. And through them, We step into a universe that was once beyond our wildest dreams. From the small blue planet we call home to distant galaxies of unknown wonders, we are becoming a species unbound. Not just solar, not just stellar, but intergalactic. Closing thought. The next time you stare at the stars, remember, one of them might not be a star at all. It might be a doorway, a whisper through the fabric of the cosmos, a reminder that the universe is far bigger and far closer than we ever imagined. And now, we're finally ready to go.